Good afternoon, all, and welcome to ALLPLAN's presentation on some of the automation tools and workflows that we've put together for small precast buildings using Planbar. My name is David Lockery. I am the Business Development Manager for Precast here at ALLPLAN. I have with me Anders Lovendal, who is our technical consultant in that segment. We look forward to showing you what we've been working on. So just to provide a little bit of background, we have been informed, what we've been doing here has been informed a lot by current practice. We know how many precasters who do these smaller projects, focus on these smaller projects, or have a sub-practice that does that, basically take existing CAD work and reuse it over and over again so as to achieve the best possible efficiency on their engineering and drafting side. And that, by and large, it works quite well. The downshot, which we've been told by many people and which Anders has quite a bit of experience with, is that when we do these things, we have to spend a lot of time on drawing, scrubbing, and QA/QC to be sure that we don't have old details, old dimensions, old annotations, old BOM data leaking into this new deliverable that we're providing. So when we set out to build a workflow that does something similar using our BIM platform, using our 3D platform, we took this as inspiration, but we think we've managed to improve on it quite a bit. So to that end, let's look a little bit at what we've done to better automate these processes. So when we build, and you can see here a nice pretty graphic of the project that Anders is going to walk us through in a little bit, but when we build a project like this, Planbar is able to draw extensively on 2D and 3D templates, and it has automated reinforcement tools and an automated ticketing engine that really make work like this a lot easier. We can start from a very high level of completion already because we have so much automation that can be used smartly, and it meshes better with your QA/QC process. We have better intelligent dimensioning tools that allow you to be confident that if I built this the right way, then the dimensions that come out are going to be accurate. So rather than going back to old CAD work, we're able to use a lot of that intelligence to do the same thing just as quickly in BIM, but with higher quality outputs and with less time required on the QA/QC side of things. We'll talk a little bit about the ticket automation because that is a very bold claim to make, and we understand that. Our ticketing automation basically consists of a couple of key components. And some of these are going to be very familiar. We have formats for title blocks. We have formats for legends and tables and bill of materials. But in addition to that, we have the intelligence to automatically fill out a lot of these things based on data that's in a model. In addition, we have what we call a ticketing configuration engine, something that allows you to determine in advance what certain pieces should look like in the ticket, how they should be laid out, what information should be highlighted, and set it so that once you've created that piece in the modeling platform, you are able then to automatically have these views, these dimension lines, these annotations, this BOM, etc., all appear on a sheet, something that gives you 85–90% of a complete ticket right out the gate, something that's linked back to the model so that if I make changes anywhere, and I can make those changes in the ticket, I can make them in the model, if I make changes anywhere, those come across to the ticket again. The goal is to be able to do these projects much like we do in CAD, perhaps choose a starting point that's a similar past project, edit, modify, iterate our way through it, and still have all of this data come out much more easily than it does today. With that, I'm going to get off of my spiel, and I am going to turn this over to Anders, who is actually going to walk us through what that workflow looks like in practice. So,
thank you for joining us for today's webinar on small precast buildings. My name is Anders Lovendal, and I will be demonstrating how to recreate this office building in Planbar. We will start this demonstration by first opening an empty drawing file and importing a PDF that has some simple views of a building to use as a reference. Many of our customers will do this import with their contract plans at the beginning of a project so that they can trace the line work and easily reference back to the PDF's information without having to switch to an additional PDF viewer software while modeling the project. Importing the PDF is as simple as dragging and dropping the file into the drawing space And then we can delete any unnecessary information like the title block from the imported data and move the line work to our project's origin point.
Yeah, we've found that for most of our precast customers, the contract documents are the best source. The 2D contract documents are the best source of input data for this sort of work. We can also import existing models from an EOR, from an architect, either as a reference or to serve as the basis for new geometry.
Now that our imported line work is in our model, we can put it into reference mode and open another drawing file for us to actually start modeling in. When we place a drawing into reference mode, we can still see the information and snap to it, but we can't edit or mess with the line work. To create the foundation slab, we'll launch our slab tool and set the properties of the slab by loading a favorite file. Throughout this demonstration, we will be utilizing favorite files because they are a quick way of applying frequently used parameter values and can be used between projects and other Planbar users in your company. For this building's foundation slab, the favorite file will apply properties we need, like the slab thickness and its location and elevation within the project. To set the boundary of the rectangular slab, we need to select 2 points in space to represent the slab's length and width and use the imported line work as a guide. Creating the exterior and interior walls will be a similar process as before, loading our favorite file that will apply the wall thickness and heights and then tracing the PDF line work. You can load different favorite files while in the command and switch the parameters for the interior walls on the fly. When modeling walls, we typically recommend adding a color fill so that it's easier to visualize where you have placed them in plan view. Later on, we'll convert these walls into precast.
And while Anders is working on this, I'll note, and probably everyone's starting to see this now, all the work to do all of this quote-unquote modeling is 2D work taking place in the CAD interface, something that everyone's drafters are familiar with.
Once we are done placing the walls, we can begin installing our various doors and windows around the building with our door and window tools. We are able to place these quickly because of our favorite files that specify the height and the width of the openings as well as the style of door or window that we want to use. After placing each door or window, we will be prompted to confirm its location and opening swing direction. We can also use normal CAD functions like copy, move, and mirror on all of these objects that we've created.
Yeah, and even though these work the same way they do in CAD, I can copy and move objects. This model, this BIM, allows me to retain some intelligence behind them when I do it. So I can see how they were placed, from what object they were copied. I can query them and count their number for bill of materials, all sorts of things that aren't really available to me when I'm just working in 2D.
If for some reason we find that we need to make a change to a door or a window type, we can always select one or multiple that we want to make a change to and bring the options menu back up to make our adjustments.
And beyond objects like doors and windows and openings, there are other ways to leverage these capabilities too. We'll see some of this later, but for instance, I can take an entire reinforcing configuration from one panel and copy it to a nearly identical panel and apply it intelligently.
You may have already noticed as I'm placing these openings around the building, but at the bottom left of Planbar is the command prompt. While in any command, you can always look there to find the next step for the current command. Now that we're done adding our doors and windows to the building, we can begin modeling our roof slab. Adding the roof slab is exactly the same process as the foundation slab, but the location of the slab in elevation is changed to account for the height of the walls. To achieve the sloped roofscape, we'll use our custom planes tool. The custom plane tool reminds me of a joke I've heard throughout my career in drafting. If you ask a group of drafters how to accomplish the same task, they'll each give you a different answer because there's typically more than one way to create the same thing in CAD software. It's the same thing here. There are a few different roofscape tools, but my preference is this custom planes tool. This tool creates a plane from 3 points in space and takes priority over other default reference planes. Once you specify the coordinates of the 3 points to create the plane, you can see that the roof and the walls adapt to the new plane. We will repeat the process for the other side of the building.
Anders made a really good point back there. A lot of folks are under the impression that CAD is much simpler than modeling is, but that's not really true with Planbar. One of the ways in which it's not true is that we don't have to do A, then B, then C, all the way through to Z. We're not path dependent like that. You can treat this program exactly like you do CAD. You can go back and forth. You can do things your own way. You can switch order. And that is a good thing for folks who have spent their whole lives in CAD to come and learn how to do this.
Now that the building has been modeled the way that we want, we can go ahead and convert the walls to be precast components. To do this, we will use our design eyewall tool, where we can first specify the factory that it's going to be produced at. We can also choose the type of wall, whether it's a solid concrete wall, a double wall, a brick wall, a sandwich panel, or even a thermal wall. We can also choose the concrete mix to be used and different finishes for the visible and invisible sides of the panels. For this, I'm going to load another favorite file to determine these options for me and select the walls to be converted. You can see that the tool has automatically assigned mark numbers to the panels and provides some weight and length information in the labels as well. We can add connections between panels at each corner of the building by going to the next tab of the design tool and selecting the corners of 2 walls. By default, Planbar includes many configurations of connections with the program, but more custom ones can be created and added to your library.
Yeah, everyone does things a little bit differently, and we try to be accommodating both in the program and when we help you folks get set up to produce in it by helping you customize all of those settings and create those objects.
In the same tab of the design tool, we can place mandatory joints where we know we want to split the wall into 2. For this building, I've placed some mandatory joints where the top of both roofscapes meet, and you can see that the program has added mark numbers for the new panels. Next, we can divide the walls even more in the Divisions tab. This is where we can specify rules for automatically placing joints. These rules are based on minimum and maximum size and weight limits of the panels that your particular precast facility can produce and the lifting equipment can handle. For this building that we're modeling, I have specified that we want to make the panels equal lengths. So when I select wall P17, the tool adds a new joint in the middle and provides a new panel and mark. Now when I attempt to run the division on the south wall, we run into an error with panel P26 due to the specified parameters of having the panels be equal length as well as avoiding divisions at openings. And you can see that on P26 the door opening extends slightly past the midpoint of the panel. To resolve this, we can go back and add a mandatory joint between the door and the window openings and rerun the division on the south wall, and the tool will recalculate the joint locations and take into consideration the location of mandatory joints.
Everyone's probably starting to get something of a feel for the value that the model, the intelligence bring to the table, but this is a really good example. If I do this kind of work in CAD, in 2D, I'm placing everything manually. Here, I can use these parameters, use the software's smarts to help me get it set up 85–90% of the way, and then I just have to pop in and kind of give it some guidance on the last little bit.
Now that we resolved the issue with P26, we can divide the remaining walls into panels that we can produce. You can see that as we continue to divide these walls up, Planbar is creating new mark numbers, and if any of these mark numbers, or I should say panels, were the exact same in geometry and reinforcement and contained all the same information, they would be marked as the same panel. But because these panels are either mirrored, reversed, or different geometry, they get their own unique mark number. Now we can move to the last step of the wall design tool, where we can automatically create and place reinforcement, lifters, casting nuts, and hollow blocks into our walls. There are quite a few options in this tool, but once you've defined your options, you can save a favorite file for future use like I have for this project. With our parameters defined, we can select all the walls at once, and after a little calculation time, our reinforcement and lifters have been added.
And this is where some of the real almost magic comes in, is that the software has the ability to do for reinforcement for complex embeds what we just saw it do for things like panel joints. The amount of automation on offer here is impressive.
Now that the basic reinforcement tool is done calculating, we can take a closer look at one of our panels and use the element plan tool to generate an automated shop ticket. For this example shop drawing, there's one drawing for the panel's reinforcement layout and another for the geometry and fixtures that reside in the panel. All the objects shown in the drawing are still associated with the building model. So if any of the reinforcement or lifters moved, or if we change the size of an opening, that would be reflected in the model. With these automated shop drawings, we can provide a lot of customization to tailor the drawings to you and your company's needs and the information that you want to display on the plans. I'll show how these piece tickets are put together and created at the end of the demonstration. So oftentimes when you reach the point where you're almost done generating piece tickets, you get told that there's a design change that you need to incorporate into the model. This is typically a drafter's worst nightmare. But with Planbar making those changes to the model and having the piece tickets update automatically for you makes it almost too easy. For this design change scenario, I want to show an example of bringing in some MEP HVAC ducting into our model and having to create new openings through the walls and adjust the reinforcement to be cut away from where the ducting penetrates. So after activating the drawing file that contains the ducting, you can see that the ducting runs horizontally through our building. And to tackle this change, we're going to use our MEP Wizard tool. This tool first prompts us to select the ducting in the model. Once all the ducting has been selected, the tool will detect all the walls that it clashes with and prompt us to choose what kind of openings we want for each location. After we make our selections, the openings are applied to our walls, and we can take another look at the panel shop drawings that have been affected by this change. You can see that the MEP Wizard tool groups all similar components together, allowing you to apply the opening parameters of your choice to one or more instances at a time.
This is actually the first time I'm seeing this tool used, and if it does what I think it does, as well as I think it does, this is going to be fun to watch.
Now, if we take a look at the shop drawing of one of the panels, we should see that there's a rectangular opening going through. You can see on the reinforcement drawing that the opening has been added and the bars have been cut around to avoid the opening, and the list of reinforcement has been updated as well to reflect this change. On the panel geometry drawing, you can hopefully see that a new string of dimensions to detail the opening has been automatically added as well. Lastly, I'll show how these piece tickets are composed in our layout catalog. Here is the layout for the panel drawings that you were seeing before. These layouts are made out of different placeholders, and with these layouts you can control the arrangement of any number of views and sections in any sequence. You can create any number of layout sheets and define the look of formwork, text, dimension lines, and so on separately for each individual view or section. You can place the title block, tables, legends, and the views and sections anywhere on the sheet. This tool is designed to be flexible and accommodate any of our customers' shop drawing needs. That concludes this demonstration, and I appreciate you watching.
Andrews was pretty thorough then. We don't have much ways of questions coming in, though one person has asked whether or not this software deals with precast components other than walls. And the answer is yes. In addition to walls, we can do all the standard framing elements, as well as having specialized tools that deal with, for instance, double T's, hollow core plank, and though I know it's fairly uncommon in the United States, filigree slab planks as well. It looks like we're all set on questions. Sorry, one also did come in. Can I create openings also in precast beams? So the utilities tool specifically, I believe, can create openings in basically what it does is define a utility element and uses it to cut through any element that utility element is supposed to pass through. And that can be used on wall panels, it can be used on hollow core, it can be used on any arbitrary shape like a beam. That said, it's not going to do any kind of design check to verify that beam is still structurally adequate. So it is something that has to be used with caution. for all the automation that we offer, we still very much require someone who knows what they're doing to be in the driver's seat. And if that is all the questions everyone has today, then I think we can let everyone get out of here early. Certainly feel free to email Anders or myself with any further questions you might have. And yeah, we look forward to seeing everyone at our next webinar after PCI committee days in about a month and a half. Thank you everyone for the time today. Anders, thanks again for the help.
Well, thank you.
Take care all.